Good morning, students. Today we are going to finish section 2 of chapter 7, ionic bonds and ionic compounds. Today we are going to continue watching our video which talks about the properties of ionic compounds. So please be quiet and listen carefully for this video. The discussion will be when we finish this video.
Let's discuss some general properties of ionic compounds. Most ionic compounds are crystalline solids at room temperature. The component ions in the crystals are arranged in repeating three-dimensional patterns. We looked at a slide earlier that showed this for sodium chloride, that the sodium ions and the chloride ions were in a cube-shaped arrangement of alternating positive and negative ions. Here we have some more examples. We have a picture of something called fluorite, a picture of grossularite, aragonite, barite, and wolfenite. Notice in all these pictures that they are crystal structures. Another general property about ionic compounds is that they have high melting points. You have to raise them to a very high temperature in order to melt them into liquid form. Our textbook discusses a term called coordination number to show how the positive and negative ions are arranged in these crystal patterns. The coordination number of an ion is the number of ions of opposite charge that surround the ion in a crystal. So in sodium chloride, each ion has a coordination number of 6. So in this drawing, the purple circles are the sodium cations, the green dots are the chloride anions. If you pick one of them out as an example to focus on, let's say that you focus on this green chloride ion here, that it is surrounded by 6 ions of the opposite charge. So to here, to there, to there, to there. That's 4 of them. And then down to a purple. And then it's not shown, but certainly a whole nother layer to this crystal would have another purple one up there. So the green dot is surrounded by 6 purple dots. That's given the coordination number 6. It helps to explain these patterns of ions. In another ionic compound called cesium chloride, each ion has a coordination number of 8. For example, the purple cesium cation is surrounded by 8 chloride anions. A third general property of ionic compounds is that they can conduct an electric current when they're melted or dissolved in water. Let's consider our example we've used a lot in this video about sodium chloride, just common table salt. With the white powder form of the salt that we're used to because we sprinkle it on our food, it doesn't conduct electricity. But if you heat it to a high temperature and create liquid salt, you could pass an electric current through it. Likewise, if you dissolve the salt crystals in water, that will conduct electricity. Salt dissolved in water can conduct electricity because the ions are free to move about in the solution. What dissolved salt is sodium ions and chloride ions freely moving around in the container of water. Remember that ions are charged particles. So when charged particles are able to move around, that is what electrical current is. Here's a check your understanding question. When can ionic compounds conduct an electric current? And the answer is B, when melted or dissolved in water. Here's a summary. Although they are composed of ions, which are charged particles, ionic compounds are electrically neutral. Most ionic compounds are crystal structures at room temperature. Ionic compounds generally have high melting points. And ionic compounds can conduct electric current when they're melted or dissolved in water.
Okay, that's it for our video.
Mister,
Yes.
can you go back 2 slides?
We are going to watch this video through PowerPoint now. and you can ask us what do you want to know. Okay? Or
Okay.
discuss. Okay. We watch the video from this point here. Okay.
Yes.
Who can read with us here?
Me, Badran.
Just raise your hands. Turkey?
Yes, Mr. So, properties of ionic compounds. Key question, what are 3 properties of ionic compounds? So, number 1, we have that most ionic compounds are crystalline solids at room temperature. That's number 1.
Yeah.
Number 2, ionic compounds have generally high melting points.
Yeah.
That's the second. And the third, ionic compounds can conduct an electric current when melted or dissolved in water.
Okay. Who can repeat the answer of this question? Mr.
Badran.
Don't mention your name. I will mention your name. Just raise your hand so I can see. Okay, Mazen.
So I'll repeat the answer. So first, most ionic compounds are crystalline solids at room temperature. Second, ionic compounds generally have high melting points. 3, ionic compounds can conduct an electric current when melted or dissolved in water.
Okay. What do we mean by coordination number? Fahd.
Mr. Coordination number of an ion is the number of ions of opposite charge that surround the ion in a crystal.
In a crystal. Okay.
Yes.
As you see here in this slide, we have sodium chloride, a part of sodium chloride crystal. Okay. Can you explain what do we mean that the coordination number of sodium ion or chloride anion is equal 6?
Can I answer?
Abdurrahman, please. Okay.
Yes.
Yeah.
Okay. So as the video said, can I answer?
Do you want me to allow you to write on the screen?
Yeah.
Okay. Stop.
Okay, yeah. 1 second. So, as in the video, he said that let's take this for example, okay?
Yeah.
So, yeah, so this ion is surrounded by six opposite charges, which are, this is number 1, number 2, then there should be 1 here, but it's not written. So this is number 3, number 4, number 5, and yeah, 1, 2, 3, 4, 5, yeah, and 6. So it is surrounded by 6 opposite charges, which is considered to be the coordination number.
Okay, let me explain it more clearly by using my pen here. As you see here, if we pick any ion, for example here, for chloride ion, here we have chloride ion, okay? This chloride ion, it is surrounded by 6 sodium cation. This is number 1 here. This is number 2, 3, 4, and here number 5. Okay, this is, and we have here, if we continue with the crystals, okay, of sodium chloride, we will have another sodium cation surrounded around the chloride ion. Okay, this means that the chloride ion is surrounded by 6 sodium cations, and the coordination number for chloride ion is equal 6. And if we study the coordination number for sodium cation, we will find each sodium cation is surrounded by 6 chloride ions. Okay? Now, I want to ask you a question. The last property for ionic compounds, as mentioned here, who can read?
مازن عدد.
Fadal Mazen.
Ionic compounds can conduct an electric current when melted or dissolved in water.
Okay. Ionic compound, it says here, ionic compound can conduct electric current when melted or dissolved in water. Okay. What about a solid ionic compound? Can they conduct electric current? The solid ionic compound?
May I answer, Mr.
مازن عدد my answer.
Okay.
ترك المشهد, Mr.
Turkey.
Okay, so we took that in chapter 2 that solids or solid particles are closely tied together, and liquid particles are flow around freely, and gas are very far apart.
Okay.
So when we melt it or dissolve it in water and it becomes a liquid substance, it is easier to become an electric current since the particles flow around with electric charge.
Excellent. Ionic compound, as your colleague here, Turkey, mentioned, ionic compound when melted or dissolved in water, the ions of the ionic compound will be freely to move, so they can conduct electric current. While ionic compound in solid state cannot conduct electric current because the ions of the ionic compound will be tightly tied together and they cannot move freely to conduct the electric current. Okay, now please open your textbook, page 207.
Teacher,
207.
teacher, did you
Yes.
put me as absent? Zoom, for some reason, kept me waiting for a long time, saying this meeting will begin soon, and for some reason,
Oh,
didn't start, and I had to get out to then get in.
okay, that's all right, Mohammed. That's all right. Don't worry. Okay,
Okay, teacher.
now let's discuss. Did you open your textbook?
Yes, teacher.
Okay, and open your notebook. And your notebook. In textbook page 207, there are questions. Okay, as you see here in the screen, we will try to answer.
Can I answer the first
the most
question?
important of these questions.
Yes. I
Okay,
would like to answer the first question.
Mr. Badran. Okay,
Yes.
you can answer. Read the
So
question.
how can? Oh yeah.
First, read the question.
Question 12. Describe. How can you describe the electrical charge of an ionic compound? So although they are composed of ions, ionic compounds are electrically neutral.
Hello?
Yes.
Yes. I answered.
Raise your hand so I can see your name, please.
Me, Badran.
Badran, yes. Read the question and
Yes.
answer.
Again, okay. How can you describe the electrical charge of an ionic compound?
Okay.
So they are composed of ions. Ionic compounds are electrically neutral.
Newton. Why?
Yes.
Why?
Because they are composed of ions.
Positive charge ions and negative charge ions, and the net charge for the ionic compound will be zero, right? So
Yes.
the ionic compounds electrically neutral. All ionic compounds are electrically neutral. Okay, who can read question number 13? Question number 13. Faisal Al
Hello,
Abdullah.
mister. Can you hear me?
Okay, can you read question number 13?
Yes, mister. Can you hear me, mister, again? So, okay. What properties characterize ionic compounds? Okay, should I answer, mister?
Yeah.
Most ionic compounds are crystalline solid at room temperature. They are generally
Crystalline
have
solid.
high melting points. They
Faisal,
have high melting points, mister.
Faisal.
Yes, mister. Yes, mister.
Because first, ionic compounds are crystalline.
Yes, crystalline. Yes, they are
solid.
crystalline.
Okay. The second,
And they generally have high melting points.
generally have high melting points. The third one,
Yes. And they can conduct an electric current when melted or dissolved in water.
excellent. Excellent.
Thank you, mister.
Now we are going to try to answer question 14 and question 15. Okay? Now, for question 14, Abdurrahman Al-Jiban, read the question and section A.
Okay. Question 14. Apply concepts. Write the correct chemical formula for the compounds formed from each pair of elements. Now, potassium and sulfur.
Okay.
I need the periodic table.
Question like this. What do we
You need to
have?
find the valence electrons, teacher. What are the valence electrons? So
Okay.
it's going to be, so K is in group 1, so it's going to have one valence electron.
One
And
valence electron.
sulfur is in 6A, group 6A, so it's going to have 6 valence electrons, but
Yeah.
you want
So
their
K2S.
charge. So it's going to be, the K is going to be one charge, one positive, and the sulfur is going to be -2. So you can do that kind of cross. You put them in the cross multiplication like this, and it's going to be K2S.
K2S. Okay. This is for A. Question 14.
Can I answer B?
May I answer
Okay.
B, Mr. Turkey? Turkey. Okay. So B, calcium and oxygen. We know that calcium has 2 valence electrons. It is an alkaline earth metal. So it's going to be +2 cation for calcium, Ca.
What's the symbol of calcium?
Ca.
Ca.
And then +2.
+2.
Since it is a part, yeah. And then for oxygen, it needs 2 unpaired electrons, or it has 2 unpaired electrons.
-2.
Yes. So when we do the cross multiplication, 2 and 2 cancels out. So it's going to be Ca and then O. Calcium oxide.
And O. Because
Yes,
they
Mr.
have same charge. Same charge, ionic charge, equal to, with opposite sign. Here, section 3, Mr. Mazen.
Yes. So we know that C is sodium and oxygen. So we know that sodium is in group 1, which is Na. And we know that oxygen is in 6. So Na has a charge of 1, +1, and oxygen has a charge of -2. So it's going to be Na2O.
Na2O.
Oh.
Excellent. D.
Do the aluminium, teacher, can I do it?
Yeah.
Okay. So aluminium is, we know that it has 3 valence electrons because it's in group 3A, and it's nitrogen, and nitrogen we know it has 5 valence electrons.
What's the symbol of aluminum? What is the symbol of aluminum?
Al.
Al with charge equal?
To 3, +3.
Positive.
And nitrogen with -3. So it's going to be
3.
So it's going to be Al3 and N3.
Al. Look at
3.
section B here.
No, it cancels
Not
out.
visible
ALN.
one.
Yeah. So it's going to be Al and N.
ALN, Mister.
N.
ALN.
Okay. This
Yes.
is for question 14.
Okay.
Okay. Write the answer in your notebook, please, as fast as you can. Okay. I'm
Okay.
going to clear the blackboard here, the screen. Let's start answer question number 15. Question number 15. Okay. Question number 15. Section A. Who can read the question?
تركي المشهد.
مازن أجد السؤال.
عاد براك.
Just raise your hand. فهد البراك.
Yeah.
Can you read the question? Question number
Okay,
15 here.
15. Describe. Write formulas for each compound. A. Beryllium chloride.
Barium
Chloride.
chloride. Who can know the symbol of barium?
It's BA, teacher.
Ba. Okay. Barium in which group?
2A. So it's going to have 2 valence electrons.
Or 2 valence electron. This means it will form a positive
2.
ion with
Yeah.
charge equal to. Chloride.
So chloride
is
is
the -1. Negative.
yeah.
-1.
Yes, because it's in group 7A. So it's
So
going to have a charge of
the-
negative.
So the formula for this
It's going to be BaCl2.
BaCl2.
Cl2.
BaCl2. Okay, this is for section A. Write the answer, please. For section B, now.
مازن can I?
تركي المشهد مستر.
Can I?
Okay,
مازن أجد.
تفضل.
Okay, so magnesium and oxygen. So we know that magnesium is a group 2A, so it has going to have 2 valence electrons, so it's going to have a positive 2 charge. And we know that oxygen is in 6A, so it has 6 valence electrons, so we know that it's going to have a negative 2 charge. And the 2 and 2 cancel out, so it's going to be MgO.
MgO. The symbol of my
MgO.
with positive 2, oxygen, negative 2, MgO,
Cancel out.
because they have equal charge. Okay, section C.
May I do it, Mr. تركي
مازن
المشهد.
أجد teacher.
No, I need another student.
تركي المشهد.
فهد براك مستر.
Okay, Fahad.
Okay, so we have lithium oxide. Lithium is Li, and it is in the first group, so plus.
+1.
Yes, and oxide, oxygen is O in 6A, and it's -1, -2, I mean.
-2. So the formula will be, the chemical formula,
Li.
make a
2O.
question.
Li2O.
Li2O.
I need to hear the voice of Fahad.
Li2O.
Li2O.
Correct.
Okay. Section
عبد الرحمن.
تركي.
مازن أجد
الرحمن.
D.
المشهد.
مازن أجد
الرحمن.
المجهد السر.
مازن عزيزة.
I need to hear
عبد الرحمن
the
جيبان.
sound of
المجهد.
مازن عزيزة.
عبد الرحمن.
صالح القحطاني. Can you read the question here?
It's going to be 1, 0,
I can't see, teacher.
You cannot see?
No.
Where is your textbook? Okay, Abdurrahman.
Abdurrahman.
Yes, teacher.
Can you answer question section D?
So calcium. Yes, calcium. The symbol is Ca,
Ca.
and it has a -2 charge.
Negative 2.
Calcium has a positive 2.
Sorry,
Calcium.
positive 2. Sorry, positive.
Raise your hand. Don't speak.
Raise my hand. وشو؟
No, no.
لا يقصد مازن.
Okay, continue, Abdurrahman.
Okay. And fluoride is
Abdurrahman,
in the
before you continue,
group 7. Yes.
calcium in group 2. Okay? Group 2
Okay.
will always form a positive charge ion. Group 1 and 2 and 3 always form positive charge ion. Okay?
And the rest are negative charge.
Yes.
Fluoride.
Okay. And then fluorine is in the group 7A, so it has a -7.
No, -1.
Eh?
-1.
Negative
Why
1.
is it -1?
Because
Why
it's
-1?
-7, which is going to
Okay.
be negative.
Mazen, what will be the
Yes.
formula, the chemical formula for calcium?
So it's going to be calcium, so it's going to be CaF2.
CaF2.
Yes.
Teacher, I have a question.
F2.
Okay, right.
I have a question.
Answer of this question. As a homework, okay, question number 19.
Okay, ma'am.
Okay.
Okay, don't send your homework after 4 o'clock. Okay.
Teacher, can you give us the typical answer?
Our homework is number 19.
I didn't hear any one of you. Raise your hands
I have a
so
question.
I can see you and allow you to talk or ask your question. Abdurrahman, what do you want?
Yes. Why does the fluorine why do you write the only one negative?
Have 8 electrons.
What?
How much charge does it need to become 8 so it can be stable? Stable.
Your question is not
Okay.
clear for me. I cannot hear you. Please repeat.
خلي الأستاذ يجاوب.
I understood, teacher. I understood. Mazen told me how.
Okay. I didn't hear you clearly, so I'm sorry.
No
but
problem.
I want to remind you that any element exists in group 1A or 2A or 3A, okay, group 1 and 2 and 13, okay, always form positive charge ion. And the charge of this ion will be equal to the number of the group. For example, lithium, sodium, potassium, rubidium, cesium, francium always form a positive charge ion equal with charge equal 1. Any element in group 2, such as beryllium, magnesium, calcium, strontium, barium, and so on, all these elements in group 2A form a positive charge ion with charge equal to +2, okay? And aluminum, gallium, indium, and so on in group 3A or 13, these metals form a cation with charge equal +3. Any element in group 15 or 5A form a negative charge ion with charge equal -3. Group 6A with charge equal -2. Group 17 or 7A form a negative charge ion with charge equal -1. Any question?
No, Mr.
Okay, that's
Thank you, Mr.
for today. You have
Teacher.
your part is question number 19. Yes, Ray?
Teacher,
Okay.
Okay, خلاص.
Thank you, Mr.
I just wanted to ask you before you go, teacher. The typical answers for 12 and 13, can you give it to us, teacher, that is in the book?
For 12 and 13.
12, yes.
Oh, I think you wrote the key questions of this section.
Ah.
Right? So it is
Yeah.
Yeah, Mr.
okay. That's,
Thank you very much.
you can memorize it from the key questions. And now, thank you for this class, for your
Thank you
good
very much.
participation here. I will go to end this class. You can go to your next lesson. Goodbye.
Thank you very
Thank you,
much.
Mr.
Thank you, Mr. Goodbye.
Bye bye.
Jabbar.